If you don't get this Name That Tune, there is a huge chunk of American culture that you are obviously missing from your life. We're going to talk now how to check the assumptions for regression. And there are 5 of them. Up to now, usually it's stuff like we just need normality or we need our sample size to be large enough. That's not going to work for regression. It's not like if you get a large enough sample size, you're guaranteed to get good regression. No. So we have all 5 of these assumptions we need to check. The good news is you can check all 5 all at the same time with one easy thing called a residual plot. Let me show you what a residual plot is by looking at a data set. Okay, we've got the price of popcorn as it relates to the number of movies produced. The more expensive the popcorn is, the more movies that are made. Are they related? I don't know. We can talk about lurking variables. The point is, when I talk about a residual, the residual is from each data point, how far up and down does it have to go to get to the line? This one here has a negative residual because he's below the line. This guy right there has this big positive residual because he's above the line. Negative residual and positive residual. So you can think of the data points like fixed points on a wooden board, and the residuals are springs. And the regression line is this pole, and when we let go, it snaps, and the best line, what does it mean to do regression, is to find how to minimize these residuals. It's actually minimizing the residuals squared, and the residuals are only in the xy direction. They're not allowed to swivel out. So these would be springs in a groove. I don't know exactly how it works, but if I plot what those residuals look like, it would be kind of like on my calculator changing my window. I'm going to change my calculator window to go along the, wow, that was jiffy. I'm going to change my calculator window to go along the regression line, if that was a nice square thing. Calculator windows don't work like that, right? You can only zoom in and out on both axes, but if you could make this diagonal window, what would it look like? You'd have something like this. Now notice my regression line is now right in the middle. And I'm going to call that 0 because the residual says how far away were you. And notice this dot right here lands right on the regression line because here he was right here, right on the regression line. There's another one that's pretty close. This guy right here was high. Right here he shows high. This guy right there, these two are low. They're low down there. So this residual plot shows me a zoomed in picture along that regression line of where my data is. So you're saying to yourself, why do we have to look at this? We could look at the original one. There's a couple of reasons. One is more complicated models, which we will not get into in this class, still use residual models. And so we want to train you on that's the proper way to look at regression. But also it'll help emphasize, instead of being distracted by the linear trend, we've taken that out. We've taken the regression out of the residual plot, and now all that's left is just what is randomly scattered there. Okay? So what do you want to see in a residual plot? This is a good residual plot because I just see random dots scattered all over the place. That's what you should see. If you see a random plot with no real distinct patterns, that means all 5 of these assumptions are all met at the same time. Now, if you do see a pattern, if you don't just see randomness, that indicates there's a problem, and you can identify which problem it is. We'll go through in another video how to see those problems. But this is why a residual plot is so valuable, is you can look at it at once and see all 5 assumptions.